Do you see my screen?
Yes, please.
Okay. Mhm. Okay. So, hi again, everyone. My name is Konstantin Kondius, and I'm going to represent our article with subject threats detection and analysis based on SYSMON tool. So. Nowadays, the community is witnessing cyber attacks during which malware infects a machine and it quickly diffuses within the network infrastructure of an organization. This work attempts to answer in a clear way the following key questions regarding the optimal initialization of the SYSMON tool towards the identification of lateral moments in the MS Windows ecosystem. So nowadays, the known techniques based on SYSMON tool prepared in this work were executed against targeted clients and compromised servers related to each attack methods. We give the proposition of log-oriented MS word regulatory policy, allowing the optimal information related to potential lateral movements methods. Designed laboratory use specification of deploying and configuration SYSMON, imitation of an attack in laboratory conditions, and its investigation by implicit science, the processing of threat analysis using the SYSMON tool. So let's go to the next slide, threats investigation using SYSMON. You can see here four parts, which include to this block. And let's go to the SYSMON Windows System Service. And System Monitor, or SYSMON, is a device driver and Windows system service that remains resilient across system reboots. It provides detailed info about possible network connections, creation processes, and files creation time changes assigned for monitor and log system activity in Windows event logs. And you can see on the screen, there is a couple of steps were made. To collect Windows log, the WinLog bit software was installed as a collector. SYSMON tool itself was set up also. So let's go next. In this paper, we designed the architecture of the threat search laboratory. You can see it on the figure 1. Based on ELK stack, Elasticsearch, Logstash, and Kibana, quite modern stack nowadays for collecting, processing, analysis of data, events, logs, and so on. The target host was deployed in the Proxmox hypervisor. You can see it on the figure 2. And the SYSMON module handles event logs, entries from the system monitor, which is a Windows service, and device driver that records system activity to the event log. The next block is about using of SYSMON methodology for implicit threats investigation. Implicit threats are considered the threats that are not detected by the security software installed at the user workplace. This includes zero-day threats, malicious actions performed by the user knowingly or unknowingly, and attacks stretched over time. So under current investigation, we use the following SYSMON events codes, which you can see on the slide. We make the investigation under the following stages. The first stage is consider the advanced persistent threat style attack in a Windows environment. So when mimikatz is detected in the first stage, it usually indicates the following 3 things. The first, its attacker has gained a foothold in the network. The second, its attacker managed to escalate privileges to run mimikatz. And the final one is attacker is most likely using mimikatz to obtain credentials to attempt horizontal distribution across the infrastructure. At this stage of detection, mimikatz can provide insight into where the attacker is in the life cycle and what they might do next. Stage 2, its next analysis revealed a malicious document that the user had opened through the email. After the user accepted the security warning, the document executed a malicious macro that made a Windows call to create an instance of PowerShell. This instance of PowerShell executes a script wrapped in a malicious macro. And the next stage is about to add the following on the screen query to ELK. And based on this result of the query, several key value pairs were manually selected that are important to create a basis for future search. Stage 4, next we analyze the relationship between parent and child processes in Windows. This combination is not inherently harmful in WMI, creates a PowerShell instance, but it's a technique used by attackers. And stage 5, finally, the command line process confirms that this PowerShell instance created by WMI is malicious. And in our example, at earlier phase of the attack lifecycle detection, a PowerShell again running on the machine was detected. SYSMON records all activities that occur on a machine, such as all activities performed by a specific process. Besides, all malicious actions performed by the malicious PowerShell process are also detected. So next slide is related to new user account. So creating a new user account is a common technique used by attackers to establish resilience. SYSMON tracks registry changes, and when new accounts are created, they are added to the registry path on the screen. As a result of the investigation, we found out that from SIEM perspective, the account was not created. But in reality, that may not be true. It's also important to understand that threat hunting is data-driven. So if there is poor or missing data, it's likely to produce incomplete or misinformed results. The last part of this block is network connection. So in this phase, the attacker examines the network environment to gain an understanding of how users interact with the network. Ideally, attackers want to expose network services such as shared document storage or internal server used to store documentation about the network. So the following types of attacks have been identified. ARP scan on the local network to discover all hosts on the same subnet. The next is collecting information about the domain, such as version of the Windows server, the forest domain, the IP address of the domain controller, and the LDAP schema for that domain. And the last one, recursive DNS queries were performed on the domain controller to obtain a list of host names of the machines in the domain. Let's go next. So next topic is about zero-day threats and IOC-based approach. IOC means indicator of compromise. When a zero-day threat appears, as a rule, compromise marks appears after a certain time, and based on them, a rule of SYSMON can be created. Hypothesis generation when using the IOC-based approach is based on the search for indicators of compromises in the protected infrastructure. In case of incident, such an indicator can be the IP address of the attacker's control server obtained from the threat intelligence database. According to the threat intelligence, which you can see on the screen, IP address which ends by 186 is used by malware. The query results show that the host was making network connection to the malicious IP address on ports 443 and 843. As a result of testing the hypothesis, the indicate incident was discovered. In addition to the IP address, the other indicators such as SYSPRO32.dll files or user prep registry value can be used to detect this incident. Okay, next part is about SYSMON and tool-based approach. This approach is based on highlighting the characteristics, features of hacking tools, such as command lines, channels, PowerShell commandlets, or network signatures. To steal user credentials, the attacker used the well-known Mimikatz utility and its PowerShell version invoke Mimikatz, which uses the reflective injection technique to download Mimikatz to the target host. A hypothesis that invoke Mimikatz utilities could be used in our infrastructure to dump user credentials was confirmed during the investigation. And tool-based approach is quite reliable. To bypass such detection, an attacker would need to customize their favorite tools, abandon their use altogether. Next slide is about SYSMON and TTPS-based approach. So the TTPS-based approach is aimed at detecting the attacker's tactics, techniques, and procedures, or in other words, his behavioral patterns. Therefore, when hunters use this approach, it will be most difficult for an attacker to avoid detection. Our platform implements IP address enrichment based on the threat intelligence for all network connection events, which allow us to prove our hypothesis. Regarding conclusion of our article, Threat Research Lab architecture is developed and an advanced persistent threat style attack in a Windows environment is considered. This laboratory can be used to study threats in a real environment with the possibility of conducting a full analysis of threats as well as their simulation for research purposes. The example considered concrete techniques that often occurs in real incidents, including included target attacks for their detection. And the proposed method has a great perspective to apply. It can be extended with aid of more advanced telemetry and special tools. Since the development of EDR, endpoint detection and response plus solution attackers techniques are becoming more and more sophisticated and often allow them to bypass detection rules that use standard operating system, audit capabilities, and free tools. That's all from my side. Thanks a lot for your attention. And please ask questions if any.
Thank you very much for a very interesting report. Dear colleagues, have you any question about this report?
Can I ask you?
Yes, please.
Sure.
Thank you very much for your presentation. And my question is the following. Maybe this question is very general. You thought about telemetry systems, and which main particularities of such a system as object of cyber attacks, and what about vulnerabilities and specific threats for such systems? Thank you.
Yeah, so
I mean, maybe there are some specific vulnerabilities of communication protocols and something. Well,
vulnerabilities on low-level protocols wasn't included to this article. Basically, we investigate Windows event from different places inside the Windows operation system, and also we look at some other examples, but not so low level. Yeah, so we include investigation of email malicious, new user account creation to start getting data as a new account, network connections, capabilities to impact the system. So low level.
I understand that there is some other domain, but my question was caused by I saw in your last slide mention on telemetry system. It's
yeah, it was mentioned as one of the steps which can expand this article. Yeah, it's adding more efficient telemetry.
Okay, thank you.
Thank you. Are there more questions to reporter? Oh, thank you. That's very interesting report.